Okay, here's your original function written with the square root symbol instead of a rational exponent. There's the graph. And it looks like there might be a point of inflection at this point right here. And by the way, the domain of the function is x is greater than or equal to 0, or using interval notation from 0 to positive infinity. If we look at the graph of the first derivative, there's the graph of the first derivative. It's never equal to 0, so that means the original graph has no horizontal tangent lines. And the first derivative is always positive, which means the original function is always increasing. And that's what this looks like right here. If we go to board 3, here's a graph of the second derivative. And notice that the second derivative has a value of 0 at about 0.157. And that to the left of 0.157, the second derivative is negative, which means it's concave. That's supposed to be a downward symbol. And to the right of that number, it is positive, which means the curve is the original function is concave upward. And since the second derivative changes sign, we have a point of inflection there. Okay, now how do you arrive at that conclusion algebraically? Well, here's the first derivative, 20x plus, think of this as x to the 1/2, which is how it was originally written. So 1/2 times 5 is 5/2, x to the minus 1/2. The second derivative will then be 20 minus 5 over 4x to the 3/2. When does that equal 0? Here's the steps to reach that conclusion. X is, the second derivative is 0 when x is equal to 1/16 raised to the 2/3 power. And here are some test values to the left and to the right of that critical number. Concave down to the left, concave up to the right, because negative here, positive to the right. There you go. Hope that helped. If you have any questions, post a comment.